Good morning, ma'am. This is Harshi Reddy from CSC A section, and my topic is about drift currents. In this PPT, you can see that introduction to drift currents, charge carriers in semiconductors, drift velocity, mobility, electric field and drift current, and conductivity of a drift and semiconductor devices, and lastly I will conclude it. Introduction to drift currents. Definition of a drift current is drift currents are the flow of charge carriers, holes and electrons in a semiconductor due to an applied electric field. And importance of a drift currents are essential for understanding the behavior of semiconductor devices. And charge carriers in semiconductors. Electrons, negative charge and holes all act as a positive charge. Movement of a charge carriers or charge carriers move randomly in the absence of an electric field. Drift velocity. Drift velocity is the average velocity of charge carriers in the semiconductor under the influence of an electric field. Formula of a drift current is Vd equals to mu V, where Vd is drift velocity, mu is mobility, E is electric field strength. And we can see the derivation of a drift current that is equals to by applying the external electric field, the charge carriers are forced to move in a particular direction which continuously constitutes electric current. This phenomenon is known as drift current. Let N be the concentration of electrons in a semiconductor, is drift with field, then the current density of a drift is J equals to NEVD. And by simplifying this, we can see current density equals to small e into capital E into small n mu n plus P mu P. And mobility. Definition of mobility. It is denoted by mu is a flow of how easily charge carriers move through a material under the influence of an electric field. Factors affecting mobility. Material type, impurities, temperature can affect the mobility. Relation between electric field and drift current. Drift current is directly proportional to electric field strength, where electric field ID equals to Q into N into mu into A into E, where Q is charge, N is charge carrier density, mu is mobility, A is cross-sectional area. Definition of conductivity. Conductivity is denoted by sigma, is a measure of how well a material conducts electricity. Relation to drift current. Higher conductivity leads to higher drift current. This part. Semiconductor devices. Applications of semiconductor devices. Drift currents play a crucial role in the operation of semiconductor devices such as transistors, diodes, and integrated circuit control of a semiconductor. Understanding and controlling drift currents is vital for optimizing devices' performance. Conclusion of drift currents. Drift currents are essential for semiconductor device functionality, influenced by factors like electric field strength and charge carrier mobility. Importance of a drift currents. Understanding drift currents is fundamental for designing efficient and reliable electronic devices, and drift currents are essential for semiconductor devices functionality, influenced by factors like electric field strength and charge carrier mobility. Importance of drift currents. Understanding drift currents is fundamental for designing efficient and reliable electronic device. And thank you.